Hey, Integrated 1 students. So today we're going over polyhedra. Polyhedra is plural for the word polyhedron. So polyhedron is a kind of shape, and polyhedra is plural for polyhedron. So polyhedra is multiple polyhedron. So what is a polyhedra? It's a fancy word for a shape that you've probably seen a lot of. Here is an example of a polyhedra. It's just a box. Spoiler alert. A polyhedra is a shape that takes a polygon. So this is a polygon right here. We've talked about polygons in the past. It's a rectangle, two-dimensional. And it takes that polygon and extends it. So extends it to occupy a space, a three-dimensional space. So in this example, we have a rectangle right here, and we have a rectangle right here. And then these faces of the polyhedra connect those two rectangles, making up a three-dimensional space. So that's a polyhedra. You'll need to put a definition of polyhedra in your assignment document. A convex polyhedra is a very specific kind of polyhedra. And they're kind of hard to picture, but a good test for whether a polyhedra is a convex polyhedra or not is if you could take any 2 points within your polyhedra. So in this case, within this box. And if you drew a line between those 2 points, would the line always, no matter what, be contained within the polyhedra? So this is a good example of a convex polyhedra, this box. Because no matter where I put 2 points inside this box, if I connect those 2 points, the line connecting those 2 points will be contained within the box, no matter what. If you want to see an example of a non-convex polyhedra, shape G in your assignment document. So when you scroll down, you'll see a bunch of shapes, A through L. Shape G is the one non-convex polyhedra in all those shapes. Because if you look at that shape, there is a place at the top of the shape where you could put 2 points inside that polyhedra, draw a line connecting them, and part of that line would be outside of the polyhedra. So that's an example of a non-convex polyhedra. But this box would be an example of a convex polyhedra. And again, that's because any 2 points within this box, if you draw a line between them, that line is completely contained within that box, within this box. A net is another definition that you're going to need to put in your assignment document. This is to get us familiar with the terms that we need to learn about polyhedrons and their properties. A net is like if I took this box, here's the box again, and I unfolded it and laid it out. So if I took the whole box apart and laid it out, you'd have a bunch of like rectangles that are bigger and smaller than each other laid out on a table, just like a flat cardboard template that I could refold to make the box. That flat cardboard template, the unfolded box, is a net. So you'll see some examples in your assignment document, some questions you need to answer about nets. The last thing is that, and we'll go over this in the PM session, but that table at the very end of your assignment document is a table that is relating the number of vertices. So a vertex, and I put this in the assignment document, but just to make it hopefully easier, a vertex is where some lines meet in a polyhedron. So here's a line right here, here's a line, and here's a line. So 3 lines meet in a vertex. That's called a vertex right here. So if you look, there's 1, 2, 3, 4, 5, 6, 7, 8 vertices on this cardboard box, this polyhedra. The other term is faces. Faces they're exactly what you might think they are. This is a face. This is a face. This is a face. All of the outside surfaces of this box are a face of this polyhedra. And the last thing is edges. And the edges are, again, what you might expect. It's the edges of the polyhedra. So the edges of this box. And then you will find a relationship between those values. So the number of vertices, the number of faces, and the number of edges in a polyhedra. And that is called Euler's formula for polyhedra.